Welcome back to the PLC Professor Workshop. This lab project discussion lecture is in support of M26. That's a lab project in part 2, and it's, you could say, semester 2. Our CCW Micro 800 training course is broken up into part 1 and part 2, semester 1, semester 2. And in semester 2, part 2, M26 is a lab project. We're going to take a previous project that used set reset, latch unlatch logic for a sequence and convert it to sealing logic. This is one of the number of projects building up to M27 where you're going to write programs for the virtual machine. And you can find this lab project in either second edition or third edition of the part 2 of the manual. So let's get at this. This lab project can be found in either one of these two manuals. It's not going to be found in part 2 of the first edition, but it is found in the second edition and the third edition. Keep in mind, if you have the second edition, that's good, but you can no longer buy the second edition of the manuals, just the third edition. So if you're watching this video without having the manuals, you're looking for the second manual there, part 2, third edition. This little bit of code that we have here was M26, and we were about to enter into the final and largest project of this entire course. We had this last little bit of code to deal with. The previous lab project, we had used set and reset, or rather latch and unlatch. A set, reset, or latch unlatch, we set a bit once something has happened, but we don't have to keep the bit at the end of a true rung. In other words, if the rung's true and it sets the bit stays 1 until you execute a reset against that same memory location. Whereas with what we're doing now, we're using sealing logic, and you can see that we added a branch around. If we look at rung 1 here, the branch around as we use the memory location of the coil with a true if on to seal in if this logic changes. So if we were to turn on input 0, we'll do that. We'll go over here and turn on input 0. You see that the top half of the rung is false. You see the blue right here at the end of the upper branch. But the lower branch keeps the rung true and keeps this instruction telling OK to start that it's on, even though the rung has gone false. So we seal it in. I'll turn that back off. And in the lab project, what we did is we had you turn on input 5, right here, the start push button in rung 2. We turn on input 5, rung goes true, and then it seals itself in. So after you've released the start push button, then cycle running is still set to 1 because it's sealed itself in. And the two conditions that can reset cycle running, if you want to call it reset, or rather to turn it off, would be if input 3 or input 4 went on. Now this is ANDed because this says if this is true and input 3 is off and input 4 is off, then cycle running. So if I turn on input 3, back off, you see it dropped out cycle running. I can turn on input 5 again over here in our simulator, and now I can do input 4 on and back off again, and you see that it drops out. Well, I had left input 5 on. Turn on input 4, you see it drops out cycle running. So let's turn input 5 back on and then off. It's a momentary push button. So we push the start push button, it says cycles running. What you don't see, and we actually don't care about it right now, is the output file. Typically, if the cycle is running and none of the steps are complete, something would happen to cause something to move or something to change in the process. And the state of these three sensors down here, input 0, 1, and 2, right now you can see 1 is off, and so is input 1 and input 2. So remember, blue means on, off, and or false. So all three of these inputs are off. True if on is going to be false if that's off. So let's turn on input 0 momentarily. Rung goes true. I turn it right back off. Step 1 is now complete. So input 0 only had to be on momentarily. And so step 1 was complete. Now, once step 1 is complete, it's going to cause something in the output file to energize a solenoid valve, turn on a motor, which is going to cause input 0 to go back off. So there would be a slight delay between when step 1 was complete and this went off. So step 1 is complete down here. Now we're looking for input 1 to go true or on. So we turn on input 1, and you can see now step 2 is complete. And if we look down here for step 3 complete, step 2 has to be complete, input 0 has to be off, and input 1 has to be off. Well, actually, yeah. So we turn off input 1, but you see the rung's still not true. We have to turn on input 2. Turn on input 2, rung goes true, step 3 complete. Now we're looking down here for input 0 to go on to complete step 4. So I can turn off, I can't turn off input 2 because the input 2 has to stay on. So I just turn on input 0. Step 4 is complete. So really the process is more or less complete, but to get it to reset, remember we don't have reset instructions and we don't have any instructions in the step complete rungs. These 4 rungs, 3, 4, 5, and 6, there's nothing in these rungs to reset the step complete. We're doing that by moving a 0 into the double integer step complete, and that'll set all these to 0. So as soon as input 0, 1, and 2 are back in their home state, that means input 0 off. Now you can see we're almost done. Input 2 off, and watch. That rung's going to go true down there and going to move a 0 into all the step complete bits. See? So now the cycle's running. It's ready to start again. Now let's start it again. Turn on input 5. Cycle is running. Turn on input 0. And then something moves in the process. It turns off input 0. But step 1 is still complete. Now we turn on input 1, something moves, and then after a while it turns off input 1. So we have 2 steps complete. Now if I hit the reset button, which is 4, okay, that resets it back to the beginning. So I can start again by turning on input 5, and I see that the reset button is still pushed. Input 4, I forgot to let go of it. That's the thing about using the simulator as opposed to a digital field device simulator with momentary push buttons. If this were one of my digital field device simulators, I would have pushed input 4 and then let go. It wouldn't have stayed on. Okay, so we have cycle running. Now we want to turn on input 0, and something happens in the process. It goes back off. Then after a while, input 1 comes on. And now step 2 is complete. And now input 1 is going to go back off, input 2 is going to come on, and step 3 is complete. Now we did the reset, we didn't do the stop. Okay, the stop push button right here, input 3, we'll turn that on. So we stopped it, but notice it didn't reset, it just stopped. If we turn off the stop button, let go of it, it's a push button, then it starts up again. In other words, when you hit the stop push button 3, cycle is no longer running, so you drop out these. So it doesn't reset the steps that are complete, but it won't allow you to complete step 4 until the cycles are running again. Now, I still have input 5 on. That's a push button, so let me turn that off. That was a mistake. So if I let go of the stop button 3, see, it doesn't start up again. You have to hit input 5 to get the cycle running, and now we're right back at this last step that we did. We completed step 3, so we'll turn on input 0, and now we've completed step 4 down here. And once we put input 0 off and input 2 off, then we're back in the home position. So watch the last rung here. 0 is off, 2 is off. We move a 0 and we clear everything, but the cycle's still running. So once we start the cycle running, there's only 2 things that will get rid or extinguish the cycle running bit. and that's the stop push button or the reset push button. Either one of them will extinguish cycle running. And then to get the system running again, you have to do input 5, the start push button. This is real simple logic, and you can reset it with the method we have down here. In other words, if step 4 is complete and the sensors are in the home position, then it's going to move a 0 in, and that basically resets the step complete. That doesn't get rid of cycle running. Now, let's do this. Turn on 0, then off again, turn on 1, then off again. So now you see we have step 1 and 2 complete over here. If I do a reset, and a reset is input 4, that killed everything. Now, it's still okay to start because the sensors are in the home position. But if we had reset it with one of the sensors not in the home position, then you would have had to have gotten it back to the home position before it would be okay to start, and you could run it through another sequence. So that's just a little bit of logic that was at the beginning of M26. The bulk of M26 is an actual process that we're starting that will take up the rest of the lab project.